Hello, hello. Welcome to my final and last and final portion of this paper, paper 2, 2021 Science, which is Chemistry GCE, Section C. There are 3 questions, but we're only told to answer 2, but we have answered all of them. This part was tough. Let me just confess. Answer 2 questions. C1. Lime is an important compound in industry. Okay. Set the chemical name of lime. My answer here was is calcium hydroxide. Calcium hydroxide. Second question, describe how lime is obtained from limestone on a large scale. Include an equation in your answer. Remember calcium, okay, let me just say, obtained by thermal decomposition of limestone to obtain burnt lime, which is mixed with water to obtain calcium hydroxide. The calcium hydroxide, which is our lime. So this calcium carbonate exists in 3 forms, which are chalk, limestone, and marble. Chalk is the most loose. Okay, same composition, same formula, but how tight the bonding in short. Chalk is loose. Limestone is a little bit hard, and marble is the hardest. It's the most compact because the bonding there is different. Number B, the question reads, where is it? Number B, give 2 uses of lime. 2 uses of lime. B1, neutralizing acidic farmlands. Then B2, or maybe 1, the second one, this is number 1, this is the second one, used to make plaster of Paris in hospitals to help mending of bones. The white stuff that is usually placed in people's necks, people's legs, okay, and to give them time for their bones to heal. Those are just some of the 2 of the many uses of lime. Okay, CBU2, what environmental problem is likely to arise or be caused by large-scale production of lime? Suggest a possible solution to the problem. That is 5 marks. 5 marks, people. This part was tough, but I tried to go through it this way. Large-scale production can lead to a number of factors or effects on the environment, like white powdered lime covering the ground, which may lead or may cause poor vision when blown by wind. Therefore, you will have this lime flying all over from the industry. It will be part of those, it will escape one or another. Okay, if breathed, remember, lime is mined, or calcium carbonate is mined. Therefore, in the production, the whole process, it will stain the environment. If breathed in, it can cause dryness of throat. Okay, it will cause, because it absorbs water, it's soluble in water, so it absorbs water. It can cause excessive alkalinity, let me say alkalinity, excessive alkalinity in rivers. Okay, I think I was correct. Excessive alkaline rivers if washed by rain. Look at me. If washed by rain or stream, and also absorbs carbon dioxide, which if too much can deprive lower plants. Okay, it absorbs carbon dioxide. So if it's a lot of it along the river, in the grass, it will actually absorb a lot of carbon dioxide, which may deprive lower plants. Otherwise, calcium carbonate or calcium hydroxide is almost everywhere, even in the water to drink, because it's found underground in many places. And in some places where it's a lot, it may even lead to land sinks or landslides, because it keeps on dissolving in bits. Okay, so it actually dissolves in water to form, I'll give us that. Lime in the environment can be washed off using water or reacted with ethanoic acid. Okay, ethanoic acid. I think that's one of the solutions. Those are some of the solutions I could think of. This question was tough. Okay, but I think that would simply earn us something. Question C2, indicators are pigments that can be extracted from flowers. Okay, fruits or roots and are used in acid-base titrations. Describe how you can extract dyes or pigments from flowers. Okay, my answer here to C2. My answer is cut relevant pieces of the plant flower, therefore petals, for example, which have color, and place them in a jar of water. Okay, appropriately. Amounts will depend on the amount of plant material you have. Simmer or heat until they fade. Therefore, they lose their color to the water. Then concentrate. You concentrate. That would be one way in which you can extract pigments from plants. We go to B1. Question C2, B1. Name one salt that can be prepared by titration in the laboratory and give a reason why titration is suitable for preparing the salt. That is B1, C2. My answer is sodium chloride, which is a neutral salt of sodium hydroxide and hydrochloric acid. Although you can still obtain it maybe by reacting sodium metal with hydrochloric acid, but I've specified how this can result from titration. Sodium hydroxide and hydrochloric acid, it is soluble, therefore titration becomes a perfect method. Titration is usually done to make soluble salts. If the salt is insoluble, there's no need of making all those measurements. Just put it in and then it will precipitate. So it is soluble, that is why titration becomes a perfect thing. B2 reads, describe an experiment you would carry out using an indicator solution extracted as described in A to show that it is an effective indicator. I think I've not answered this one very straight up, because it's saying describe an experiment you'd carry out. I think I have, though. You test the pigment color changes in both acid and alkaline solutions. That would be an experiment to test the pigment color changes, if any, and if its color changes are significant. Therefore, if there is a way in which it changes when placed in acid or placed in base, the pigment can be used as an indicator in titration. Therefore, acid-base titration. That's the best I could go. This question was tough for me. It's like it's coming a little bit on the boundaries, because talking about organic indicators or natural indicators is not so much in our ordinary science. But that's something I could think of as I was answering this. My last question was very nice, which is C3. A hydrocarbon V, which contains only 3 carbon atoms, was bubbled through bromine solution, and there was a rapid decolorization of the solution. Identify the hydrocarbon V. This is propene. Okay, the identity test for alkenes is that they decolorize bromine water. Propene is the hydrocarbon. Number C3A2. Draw the structure of V. That is propene. You can whether you put the double bond here or there, it's the same thing. Number 3, A3. To which homologous series does V belong? That is alkenes. 4. C3A4. Write the general formula of the homologous series where the hydrocarbon V belongs. This is the general formula for alkenes. Okay, so number C3 was really a very good question. Number B, explain the danger of burning the hydrocarbon V in limited oxygen. Carbon monoxide will be formed, okay, which is a respiratory poison. You breathe it in, it simply suffocates you or asphyxiates you. Number B2, write the balanced chemical equation for the reaction in B1 above. 5 marks, 5 beautiful marks. This is the answer for B1. Carbon monoxide is produced, which is a respiratory poison. Then the equation would be this: oxygen, carbon, then write your monoxide there, then you balance it up. This is just energy, which should be in form of heat. Okay, and if the energy is if the oxygen is very limited, a lot of carbon or soot will be produced on the products. A lot of soot or smoke, as you may call it. My last question there reads, under suitable, that is C, under suitable conditions, the hydrocarbon V was polymerized, and a polymer W was produced. Display the structure of polymer W. The structure would be this, okay, where N is the number of monomers that have joined to make this polymer here. Okay, so that is the end of this paper. Okay, hope you managed to understand one or two things. Leave your comments or suggestions or corrections where I rushed, because if I delay, I may actually take 2 hours, okay, for the whole paper. Okay, have a good time in your science life. Bye bye for now.